Next to clean water and antibiotic use, vaccines are probably the most important intervention in current healthcare in the world right now. And developing new vaccines is critically important for keeping up with the public health need to reduce infectious disease. So we need to always be developing new technologies in those areas so we can be ready to quickly scale up and stay ahead of any infectious diseases that suddenly arise in the world, and that can happen at any time.
Established by Boston Children's Hospital in 2016, the Precision Vaccines Program is a platform to enhance collaboration between academia, government, and industry to accelerate development of vaccines for vulnerable populations such as the young and the elderly. The concept really grows out of the realization that whereas vaccines were traditionally developed as one size fits all, that one vaccine formulation would be applicable to any individual in a population, to the contrary, increasingly we realize that subpopulations vary, sometimes dramatically, in their response to a vaccine. Coronavirus, of course, these days, that's by far the bulk of our focus. The Precision Vaccines Program here at Boston Children's Hospital, we believe, adds unique value to the international effort, the race to develop a safe and effective coronavirus vaccine. Our local team here in Boston is comprised of approximately 30 individuals. It's a very diverse group, different career phases, ethnicities from all over the world, and very different skill sets.
We have clinicians who are very close to the healthcare side of this, and you have people like me who are very much on the molecular and biochemical side of research. Having all those people together is quite special.
We have collaborators all around the globe, which we work very closely to really understand how vaccines work. The two major sites that we're working in is the Gambia and Papua New Guinea, which in the last year I have visited both sites, which was just fascinating.
So it's very hard to overstate the positive impact of vaccines on the world. And we're really just scratching the surface of what we could do. We're using the most cutting-edge technologies to measure the entire inventory of cells and molecules in small droplets of blood. This technology will allow us to get deep insight into how vaccines protect in early life. Up to now, vaccines have been more or less developed by trial and error. We want to now leverage the most cutting-edge technologies. We call these systems biology, approaches that can measure all the cells and molecules in a sample and measure it before and after the vaccine.
We're looking at signatures, molecular signatures that can inform us of protective responses. For example, what are the signatures that we can predict, for example, in male and female at different ages?
A lot of the research we do is on the discovery and development of various different molecules that can enhance the immune response. We commonly call these molecules adjuvants.
We are screening small molecules for their ability to activate white blood cells from newborns and elderly individuals so that we can use those molecules to add to vaccines and see if we can develop single-shot protection vaccines for difficult to immunize populations such as the very young and the elderly.
Right now, many kids, when they're first born, they may get up to 14 or 15 vaccines in the first 2 years of life. It might be theoretically possible to scale that back to maybe even a single-shot immunization strategy very close to the first days of life.
They ship to us. Yeah. We can do the conjugate.
We bought it from the website.
And we believe we're just scratching the surface of what could be done. There's a new immunologic theory that there's increasing evidence for that certain live vaccines, some vaccines are weakened versions of a germ, certain live vaccines enhance the immune system in a very general way that actually gives broad protection not only to the pathogen that vaccine was designed for, but broadly against different bacteria and viruses. This new realization could save millions of lives worldwide.
Bacille Calmette-Guerin is a very old vaccine that's about 100 years old. That is the most commonly administered vaccine in the world. BCG can actually train the immune system in ways that we didn't know until a few years ago.
Our goal, our moonshot, is to turn vaccine development on its head. What we want to do is replicate the human immune system outside the body using our tissue culture methods.
My main work is to develop these tissue constructs, is how we call them. That it is another thing as trying to replicate the immune system of a baby, but in a petri dish. The idea behind this is to be able to replicate immune responses of the baby without having to do that in actual living beings.
When this pandemic started, we already had a huge network through our Precision Vaccines network of collaborators, and so we were able to start months ago on this coronavirus vaccine effort. Vaccines are not one size fits all. We want to apply the principles of precision medicine to vaccinology. That is the Precision Vaccines program.